In October of 1944, a German fortification officer stood behind a bunker near Aachen and stared at a hole that should not have existed. Not a crater, not the clean punch of a heavy bomb, not the kind of wound that made sense to an engineer. The front wall was still there. 2 meters of reinforced concrete, more in the exposed sections, steel inside the pour, firing slit facing the approach, obstacles in front, all of it built to make an attacker stop, bring up special equipment, and pay for every meter in blood. But the bunker had been opened from behind. The steel door was lying crooked in the mud. The firing aperture was blackened from heat. Inside, the air still carried that sour smell of burned fuel, concrete dust, and men who had left too quickly. The officer walked the perimeter once, then again, then a third time slower. He was not looking for bravery. He was not looking for luck. He was looking for a machine. Because a wall like that was not supposed to lose to infantry. Somewhere, he believed, there had to be a new Allied breaching vehicle, a concrete cracking weapon, a specialized armored tool that German intelligence had missed. That was the only explanation that fit the mathematics. But there were no strange tracks in the mud, no special blast pattern on the concrete, no evidence of a heavy assault vehicle sitting close enough to do the work. Only boot prints, a burn scar at the embrasure, and the twisted frame of a door that had been taken off by a charge a trained engineer could carry in his hands. That was the first thing the West Wall taught the men who built it. The most dangerous weapon on that battlefield was not new. It was ordinary. The Siegfried Line, known to the Germans as the West Wall, had never been a decorative border. It was a national engineering bet poured into the ground. From the Dutch frontier down toward the Swiss border, the line stretched for roughly 630 kilometers. Across that distance sat thousands of bunkers, casemates, troop shelters, observation posts, command rooms, ammunition stores, and anti-tank obstacles. In the most repeated count, about and permanent works formed the system. The numbers mattered because they were the point. This was not a trench that panicked men had dug in a hurry. This was planned concrete. At its peak before the war, the construction effort pulled in hundreds of thousands of laborers, contractors, engineers, soldiers, and state organizations. The line consumed millions of tons of concrete and steel. Its bunkers were not guessed into place. They were surveyed, specified, poured, measured, signed off, and every measurement carried the same promise. Here tanks would stop. Here artillery would waste itself. Here infantry would separate from armor and die in front of concrete. The German engineer did not believe this because a minister had said it in a speech. He believed it because his profession had built it. A 155mm shell could tear open earth, roofs, roads, and men. So the fighting faces of the bunkers were made thick enough to resist it. A tank needed a path, so concrete pyramids called dragon's teeth were arranged in belts deep enough to trap it before it could gather speed. A garrison needed protection, so the firing slits were narrow, the steel doors heavy, and the interiors laid out to keep fragments from murdering everyone inside. There was a clear technical logic to every piece of it, and that logic produced a clear conclusion. To break the West Wall in an organized way, an enemy would need time, heavy machines, specialized assault vehicles, and a deliberate siege. That conclusion was reasonable. It was also wrong. By September 1944, the American army that reached the West Wall did not look like an army designed for a siege. It had just crossed France at a pace that shocked both sides. After the breakout from Normandy, German formations in the West had been torn apart, bypassed, captured, or driven backward so quickly that headquarters maps could not always keep up with the road columns. American armored units were used to movement. Engineers were used to improvising. Infantry were used to finding German positions before the Germans had finished organizing them. Then the pursuit ran into concrete. On September 11, 1944, near Wallendorf, the U.S. 5th Armored Division made one of the first breaches into the West Wall system. It did not arrive with a secret concrete destroyer. It used tank fire, infantry pressure, demolition charges, and engineers who treated the obstacle as a problem to be solved right now, not after doctrine had been rewritten. The first breach did not instantly collapse Germany. It was narrow. It was fought over. German reserves sealed parts of the line again, but something more important had happened. An assumption had cracked. The American message moving through the units was simple. This can be done with what we already have. The German message, once the reports started coming back, was harder to accept. They are doing this without the tools our calculations said they needed. The British had built specialized assault vehicles for this kind of work. Armored engineering tanks, mortar-equipped bunker busters, flamethrower tanks. bridge layers and obstacle clearing machines. The Americans had some specialized equipment in certain formations, but they did not enter the West Wall campaign with a whole assault engineering system like that built around them. On paper, that looked like a weakness. In the mud, it became something else. Because the American Army had something less impressive to photograph and harder to calculate. It had a lot of engineers. It had standard demolition training. It had flamethrowers. It had bulldozers. And it had a habit that German fortification design had not priced correctly. American units learned sideways. One company found a way to blind a bunker. Another figured out where to put the charge. A platoon discovered the best angle for tank destroyer fire. A bulldozer operator learned that the dragon's teeth could be attacked from the side instead of the front. The lesson did not wait for a manual. It moved by runner, by radio, by officer, by rumor, by exhausted men telling other exhausted men what had worked yesterday. The method that became famous around Aachen had an ugly little nickname. The blowtorch and the corkscrew. The blowtorch was the flamethrower. The corkscrew was the explosive charge. It was not elegant, it was not gentle, but it solved the bunker as a sequence instead of treating it as a wall. First, the firing slit had to stop firing. That was the flamethrower's job. A man with an M2 flamethrower had only seconds of continuous fuel and a range that forced him close enough to feel every machine gun on the battlefield looking for him. He did not need to melt concrete. He did not need to burn through 2 meters of wall. He only had to get flame into the opening the bunker itself needed in order to fight. A firing slit is strength from the defender's side. From the attacker's side, it is a mouth. And once burning fuel reached that mouth, the men inside had to pull back or die where they stood. That did not capture the bunker. It bought seconds. The engineers had to turn seconds into entry. They moved around the blind side or rear, carrying demolition in satchels or blocks, looking for the door frame, hinges, locks, and any seam where force could do more than brute power. A reinforced door was a hard target from the front, but a door is still a door. It depends on its frame. It depends on hinges. It depends on the structure around it accepting the shock. When the charge went, the door came loose. Sometimes it tore completely free. Sometimes it bent just enough. Sometimes the entry was still a nightmare of smoke, splinters, steel, dust, and men shouting in 2 languages. But the sequence worked. Blind the embrasure, break the door, clear the room, move to the next bunker. This is why the German engineer outside that bunker could not make the damage fit his expectations. He was reading the bunker as a single object. The Americans were attacking it as a chain of smaller problems. They did not defeat the concrete by overpowering it. They refused to fight the concrete where it was strongest. They fought the opening, then the door, then the men inside. That distinction was everything. A fortification is not just a wall. It is a system of human behaviors wrapped in material. A gunner has to see. A crew has to breathe. A door has to open. A defender has to choose between staying at the slit and being burned alive. The West Wall had been engineered against the destructive power of Allied hardware. The American method found the places where a hardened structure still depended on human timing. And human timing, under flame and blast, is fragile. The fighting around Aachen proved the method under conditions far worse than the first September probes. The German defenders were no longer confused rear area troops scattered by the collapse in France. Many were fighting on German soil. The bunkers supported each other. The approaches were watched. Mortars and machine guns swept the lanes. Every flamethrower man was a priority target. Every engineer crawling toward a rear door carried not just explosives but the attention of every German who understood what would happen if he reached it. The method worked, but it did not work cheaply. That part often gets lost when people reduce the story to a clever tactic. There was nothing easy about walking toward a bunker with fuel on your back. There was nothing simple about kneeling beside a steel door while rounds snapped into the concrete above your head. There was nothing mechanical about clearing the inside after the blast. When the smoke hid, whether the men waiting behind it were stunned, surrendering, or ready to fire. Ordinary tools did not mean ordinary courage. It meant the equipment was already in the inventory. The cost was paid by the men who had to bring it close enough to matter. The dragon's teeth created a different problem, and they revealed the same German misread even more clearly. Those concrete pyramids had been designed to stop tanks. In that narrow sense, they were good engineering. A Sherman trying to force its way over the teeth could high center on the concrete, lose traction, throw a track, or sit exposed while anti-tank guns opened from beyond the obstacle belt. The geometry made sense. The spacing made sense. The depth made sense. The belt was not decorative. It was a machine trap, but it had been tested in the German mind against the wrong machine. The Americans brought up bulldozers, not glamorous armored assault monsters, standard Caterpillar tractors, construction machines, machines meant for roads, runways, rubble, dirt, and work that had nothing to do with heroic battlefield posters. A bulldozer did not need to drive over the dragon's teeth. It could shove, it could push at an angle, it could work one tooth, then another. It could attack the obstacle not as a tank obstacle, but as misplaced concrete. The blade met the pyramid low, the engine dug in. The operator leaned into the machine. Mud crawled under the tracks. Concrete shifted sideways, then another tooth moved, then another. And slowly under fire, a gap appeared. The Germans had built the obstacle to separate infantry from armor. The bulldozer put them back together. That was its whole battlefield value. Not beauty, not speed, not invulnerability. A tank column on the wrong side of Dragon's Teeth was power waiting to die. A gap wide enough for armor turned infantry survival into a combined arms fight again. So the bulldozer operators kept driving. They drove vehicles with thin protection into spaces every German gunner could see. They made noise. They threw exhaust. They moved slowly enough to be aimed at. And because the line could not be crossed without them, they became some of the most important targets on the field. There is a certain kind of military mind that cannot respect a bulldozer until it ruins a plan. The West Wall helped teach that lesson. German reports from breached sectors kept circling the same confusion. The damage did not match known Allied special vehicles. The obstacle gaps did not look like clean bridge work. The bunkers were not cracked open by some new siege gun. The pattern was too crude and too precise at the same time. A door blown here, a firing slit scorched there, Dragon's Teeth shoved sideways instead of crossed. The evidence pointed toward a conclusion so plain it felt professionally insulting. The Americans were using normal tools very well. That should not have been shocking. But to the men who designed the West Wall, it was. German engineering culture was brilliant at defining a physical threat and building against its specifications. Tank height, gun caliber, shell impact, armor thickness, obstacle spacing, concrete strength. All of those things could be measured. So all of those things could be answered with material. More concrete, more steel, more depth, more angles, more reinforcement. The American solution was less tidy. It was procedural. It depended on training, timing, local adaptation, and trust in small teams. A flamethrower crew had to coordinate with infantry cover. The demolition team had to understand where a charge mattered. A tank destroyer crew had to know which aperture to keep suppressed. A bulldozer operator had to read the obstacle like a construction problem while shells were landing near the blade. No drawing in Berlin could fully model that. No concrete specification could prevent a method from improving every time it was used. This was the failure inside the failure. The West Wall was supposed to buy Germany time, not forever. Time. Time to rebuild units after the defeat in France. Time to pull reserves together. Time to force the Allies into winter exhaustion. Time to make every mile in the West slow enough that German strategy could still pretend it had choices. But a defensive line that depends on delay can be defeated by anything that destroys the timeline. And the American engineers were destroying the timeline. Bunker by bunker. Gap by gap, improvement by improvement. Every position reduced with standard tools erased another week Germany had counted on. Every copied field lesson made the next breach less mysterious. Every ordinary bulldozer cut through an obstacle that was supposed to require equipment the Americans had not brought. By the time the fighting moved beyond Aachen and into the grim forest battles and the winter offensives, the West Wall was no longer an untouched technical problem. It was a known problem, a terrible one. A costly one, but known. And once an army knows how to do something, the enemy no longer gets to charge the original price. The most revealing part of the story is not that concrete failed. All concrete fails eventually. The revealing part is what kind of thing made it fail faster than expected. Not a miracle weapon, not a secret vehicle, not a single genius. A trained system of ordinary men using ordinary tools, then learning quickly enough that the wall could not stay ahead of them. That is the difference between equipment and capability. Equipment is what appears on the inventory sheet. Capability is what happens when trained people can combine those items under pressure, change the sequence, and try again before the enemy understands the first attempt. The German engineers had looked at American equipment and calculated against machines. They had not calculated deeply enough against American habits. The habit of giving engineers tools and expecting them to solve the real problem in front of them. The habit of turning a construction tractor into a breach vehicle because the obstacle was, after all, concrete in the wrong place. The habit of treating every bunker as a lesson for the next bunker. A wall can be thick, a method can be faster. By March 1945, the West Wall was no longer the great concrete answer Germany had imagined. Its bunkers still existed, its teeth still scarred the fields. Its steel doors and firing slits and command rooms still showed the intelligence that had gone into them. But the strategic promise had been broken. American forces had found their way through in multiple sectors. The Rhine was ahead, the concrete empire was behind them, and the lesson sitting in the mud near Aachen had become impossible to ignore. The wall had been designed to resist the machines the Germans expected. It had been defeated by men using the tools they already had. A flamethrower did not look like a siege system. A satchel charge did not look like a strategic answer. A bulldozer did not look like a weapon that could embarrass years of anti-tank design. But the West Wall was not broken by how impressive those tools looked. It was broken by what prepared men knew how to do with them. The German officer at that first ruined bunker had wanted to find a secret. He wanted some hidden machine that could restore the dignity of the calculation. Something new, something rare, something worthy of all that concrete. Instead, the evidence gave him a worse answer. Boot prints, burn marks, a broken door, a blade track in the mud. No secret machine had come for the West Wall. The men had come, and the wall built against hardware had never really been built against them.